Okay, so section 5 is all about solving equations. So yesterday we talked about how to solve linear and fraction. Today we're going to talk about all the quadratics, and then tomorrow we'll talk about your radicals, your absolute values, higher order, all kinds like that. So when it's asking you to solve by quadratics, there's 4 methods that we've also done graphing, but we're not going to do graphing. Okay, so this is all algebraically. So we can solve by factoring, taking square roots, solve by to complete the square, and the quadratic formula. So what we're going to do is we're going to go through each kind. On your homework, it is very specific what method you need to use. So make sure you're showing your work that matches that same method, which matches the directions. Okay? So the first method we're going to talk about is factoring. Okay, and on these you could see GCS, difference of squares, trinomials, cubes, grouping, every kind of factoring that you've seen before. So first thing you have to do is make sure it's set equal to 0, which this one is. And then I go to factor. Well, on this one I can factor out a GCF. They both have a 3x in common. So I factor out a 3x. And I'm left with 2x plus 1. Make sure when you factor it out, you still have the 1 left over. Okay, after it's factored, you set each part equal to 0, and you solve. Now, I'm assuming you could do 1 and 2 step equations in your head. So if you don't want to show your work that you divided by 3, and you know that that's 0, and you don't have to show your work that you subtracted 1 divided by 2. I'm going to assume that you can already do that in your head. If you want to, you can show the steps, but I'm okay if you go to here. Okay, and then remember if there's more than one answer, you need to use solution sets. I do not care about the order. If you can't do solution sets, just do squiggly lines. Okay, this one's already set equal to 0. It's a trinomial, so on trinomials, you make the x, multiply to get 25, add to get 10, would be 5 and 5. So x plus 5, x plus 5. Okay, since those are going to be the same answer and they repeat, you technically only need to solve it one time, because you're going to get the same answer. Your answer is -5. Okay, now if it makes you feel better, since it's a quadratic, you can put that answer in solution sets, even if there's only one number. But you don't have to if there's just one number. Okay? Only time you have to use solution sets is when you have more than one number in your answer. Okay, on this one, the very first thing we do is we have to get it set equal to 0. So I like my x squared to be positive, so I'm going to subtract 12 from both sides. So I have x squared plus 4x minus 12 equals 0. Okay, it's a trinomial, so multiply to get -12, add to get 4. Would be 6 and -2. So this factors into x plus 6, x minus 2. And then I would set each part equal to 0. And I'm going to solve. So I get x equals -6, x equals 2. Okay, and don't forget we're going to use our solution sets. There's more than one answer. Okay, we're gonna do one more. I'm gonna combine kind of two things. A number in front of x squared, you remember what to do, and if you have a fraction. I know most of you do not like messing with fractions. So what I'm going to tell you to do, since there's an equal sign right here, that means we can multiply everything by the denominator, and that's going to get rid of your fraction. So I'm going to multiply everything by 4. So then that would give me 3x squared plus 32x plus 80 equals 0. Okay, and the reason why this is 3 is those 4's are going to cancel. So then trinomial, so I'm going to make my x 3 times 80, 240. Add to get 32 would be 12 and 20. Okay, because there's a number in front of x squared, this is when you have to split the middle. So I'd have 3x squared plus 12x plus 20x plus 80. Then I'm going to factor by grouping. So the first group I can factor out of 3x of x plus 4. Second group I can factor out of 20, left with x plus 4. So this factors into x plus 4, 3x plus 20. And then I would set each part equal to 0. And I would solve. So this would give me -4, and this one would give me -20 over 3. If you'd rather have that as a mixed number, that's totally fine, okay? Or you can leave your answer as an improper fraction. Do not use decimals unless it comes out perfectly, and this would not. So you would want to make sure, since that one would not come out perfectly, that you leave it either as an improper fraction or make it a mixed number. Okay, so this will cover different examples that you're going to see for factoring. Okay, the next method would be the square roots. Okay, when you solve by taking square roots, the whole point is to get the squared part by itself. Then when to get rid of it, you're going to take the square root. So on number 12, x squared is already by itself. So to get rid of the squared, we're going to do the square root of both sides. Okay, when you take the square root, you're going to have plus or minus. And then if I can finish that, if that's perfect, then we'll get our answer. If not, we're going to do factor trees. Since there's more than one answer, we're going to use solution sets. Okay, so before we can take the square root on this one, we need to get the square by itself. So we would need to divide both sides by 3. So I have x squared equals 27. And I would take the square root of both sides. Okay, now, I know I have plus or minus, but 27 is not perfect. So we need to take our factor tree and break down 27. So I can break it into 9 and 3 and 3 and 3. So I have a pair of 3's, So that'd be plus or minus 3. And then I have a 3 left over. So that's going to stay inside there. And that will be your answer. Okay, so I want to get rid of the squared. Okay, now don't FOIL this because this whole part is squared. So that is 1 unit. So what you can do is you can go ahead now and take the square root. So what happens is the square and the square cancel. So the left hand side is left with x plus 2. The right hand side didn't have a square, so it has a plus or minus. Square root of 14. Okay, square root of 14 is not perfect. It does break into 2 and 7, but there's nothing that's the same. So I can't break that down. So then now I do is get x by itself. So I'm going to subtract 2. Okay, but since the 2 is not in a square root, it will go out in front. Then I have my plus or minus, and then I have my square root of 14. So if it's not inside the square root, make sure it comes out in front. And then I do my solution sets because this is 2 answers. This is negative 2 plus square root of 14 and negative 2 minus the square root of 14. Okay, if both sides are squared, so square is squared, same thing, we'll go take the square root. Okay, but neither side will have plus or minus because both sides are squared. This just cancels out to be x minus 7. That cancels out to be x plus 3. Okay, then I would solve. So I'm going to subtract x. Okay, now on this one what happens? X is canceled on both sides. I have negative 7 equal to 3. Well, negative 7 is not equal to 3. So this one would be a no solution. These are not automatically no solutions. Okay, just because you can do the square on both sides. You need to make sure you solve it for x. Okay, so that's square roots. The next step is completing the square. Okay, so here are your steps to completing the square. And when I talk about A, B, and C, this is standard form, ax squared plus bx plus c equals 0. So that's standard form of a quadratic. Okay, first step is you're going to move c to the other side. Okay, so we're going to move c. C is the constant, so whatever doesn't have the variables, they're going to move it to the other side. Step 2 is you're going to divide by A. A is your number in front of x squared, so every single thing you're going to divide by A. Step 3 is we're going to take a half times b squared, and we're going to add it to both sides. Okay, because you would have just divided by A, your B might not be originally what it starts out as. It's after you would divide by A. Okay, step 4 is you're going to make it a perfect square. So the whole point of doing this is now what's on the left-hand side is going to factor into a perfect square. And then your last step is you're going to solve by taking square roots. Alright, so we're going to do, this is definitely what I think is the hardest part. So we're going to do examples of all kinds that you'll see. It might be something you want to go back and re-watch and re-figure out, because I know it's going to be the part that you struggle with most. Okay, and I also know that it's not the easiest method, but when it says solve by completing the square, you need to solve by completing the square. Okay, so the first thing we're going to do is we're going to move c to the other side. So I need to move this negative 32, so I'm going to add it to both sides. So I have x squared plus 4x equals 32. Okay, step 2 is we're going to divide by a. Well, a in this case is just 1. So when I divide by 1, it's not going to change anything. So I can skip that step. Okay, step 3, we're going to take half times b, and we're going to square it. Well, b is 4. That's my name in front of x. We're going to take a half times 4, and we're going to square that. Well, a half times 4 is 2, and 2 squared is 4. And it says add to both sides. So then I would have x squared plus 4x plus 4 equals 32 plus 4. Okay, next step. Make it into perfect square. So what happens is when I go to factor this, I multiply to get 4, add to get 4. These numbers that you get are going to be exactly the same. So that means it's going to factor into x plus 2 squared, because you'd have an x plus 2 and an x plus 2, so we can make it just squared. Okay, shortcut. It's always this number right here. That half of b is always the number that goes in there. If it's positive, then it's going to be a plus. If it's negative, then it would be x minus. Then we simplify the right-hand side. 32 plus 4, 36. Okay, and then the last step, solve by taking square roots. So we're going to take the square root of both sides, part that's squared, just love the x plus 2, and then square root of 36 plus or minus 6. Okay, then we're going to solve for x, so I would subtract 2. So I have negative 2 plus or minus 6. Since neither one of those have square roots, we need to finish it all the way out. So negative 2 plus 6 is 4. Negative 2 minus 6 is negative 8. And those are your two answers. Now I realize that this is not the easiest method. Okay, factoring would have been, but since it said solve by completing the square, that's why we have to go through all of our steps. Okay, so on this one, first step, move c to the other side. Well, that's already been done because the constant's already on the other side. Okay, step 2, divide by a. So we're going to divide everything by 9, because that's what's in front of our x squared. So I have x squared minus 2x equals negative 1/3. Okay, step 3. Half of b squared. My b is now negative 2, because it's after I divided by a. Half of negative 2 is negative 1, and negative 1 squared is 1. We're going to add that to both sides. Okay, number 4, make this a perfect square. So if you do the factoring, multiply to get 1, add to get negative 2, negative 1, negative 1. Or, we look at this number right here, that's the number that goes in there. Since it was negative, that's why it's minus. Okay, the right side, negative 1/3 plus 1 is 2/3. Okay, then I go take the square root, because that's what step 5 says. Solve by taking square roots. So I'm going to square root both sides. Left hand side is x minus 1. Okay, right hand side, I'm going to have plus or minus. Okay, square root of 2. Well, can't do anything with that. Square root of 3. Can't do anything with that, so it stays like that. Okay, problem. Can't have square roots in your denominator. So you're going to have to rationalize this. So we're going to have to multiply by square root of 3 on top and bottom. Okay, and that's before we move this 1 over. So I would have x minus 1 equals plus or minus. Square root of 2 times square root of 3 is square root of 6. Square root of 3 times square root of 3 is 3. Okay, and then solve for x. I'm going to add 1. And since this is not a square root, that's going to come out in front. And then I have plus or minus square root of 6 over 3. Okay, we're going to do one more. Okay, so first step, move c to the other side. So I'm going to add a to both sides. So I have 2x squared plus 5x equals 8. Okay, step 2, divide everything by a. So I'm going to divide everything by 2. So I have x squared plus 5 halves x equals 4. Okay, now I complete the square. So I can have, I'll take a half, okay, times b. This is now your b. So 5 halves squared. Well, a half times 5 halves is 5 fourths. And 5 4 squared is 25 sixteenths. So I'm going to add 25 sixteenths to both sides. Okay, I need to make a perfect square. This is the number that's going to go in there. So this would be x plus 5 fourths squared. Excuse me. Okay, now, the right-hand side needs to be an improper fraction. If you want to add these on your calculator and then make it improper, totally fine. If you're going to do it by hand, I need to make this be something that has the 16ths. So that means that's 64 sixteenths. Well, when I take 64 sixteenths plus 25 sixteenths, that gives me 89 sixteenths. Okay, the reason why we have to do that is because you can't take the square root of a mixed number. Especially if it doesn't come out perfect, you're not going to know if you have to rationalize or not. So then to finish, we're going to solve by taking square roots. So this would be x plus 5/4 equals plus or minus. Okay, square root of 89, not perfect, so we're going to leave that up there. Square root of 16 though is 4. So I don't have to rationalize on this because that came out perfectly. And then I would just subtract 5/4. So then your answer would be negative 5/4, because that's not in the square root I put out front, plus or minus the square root of 89 over 4. Okay, definitely think completing the square is the hardest. So if you need to go back and watch the video a couple times, then I would. Bear with it, be patient, and follow the steps as you go. Okay, last method of quadratics is the quadratic formula. Okay, quadratic formula is derived by completing the square. Okay, so what is done is this is your standard form. So it's taken standard form. When you use the method that we just did, solve by completing the square, and you solve for x, this is what you get. If you can show me the work on a piece of paper and turn it in by Friday at 3 o'clock on how you get this formula from this. Now, not printing off the internet, this is you showing your work and the steps. By Friday at 3 o'clock, I will give you extra credit. Okay? So that might also help to know who watched the video, because if you don't watch it, you're not going to know that it's available. Okay. Okay, in order to use the formula, you have to have it equal to 0. So this one's equal to 0. Okay, A, B, and C. A is number in front of x squared, B is number in front of x, C is your constant. So then we just solve. So opposite of B is supposed to be negative 1 plus or minus the square root of 1 squared minus 4 times 2 times negative 1 all over 2 times 2. Okay, I'm assuming you're pretty familiar with quadratic formula because I know you used it a lot in Algebra 1. We did it in Algebra 2 as well. So then you go to simplify. So inside the square, so I have negative 1 plus or minus. Okay, so inside the square root I have 1 plus 8. So that would give me a square root of 9 over 2 times 2 is 4. Okay, so I can keep simplifying this one because square root of 9 is perfect. Square root of 9 is 3. And since I don't have square roots, I need to finish all the way out. So negative 1 plus 3 is 2. 2 divided by 4 is a half. Negative 1 minus 3 is negative 4. Divided by 4, negative 1. And then I take my two answers.